there's a question.
Still,
Good.
sir, we had one doubt.
Yes.
Regarding the return of when a fault is generated by the intermediate node. Sir, if there is a requirement that a fault which is generated, if that is also being logged somewhere,
Okay.
that which intermediate node is generating the fault, then in that case the SOAP message is sent back to the sender only.
Right,
To
then,
any other intermediate node.
right.
So sir, in that case, if we want another intermediate node logging that activity, logging this fault generation which is done,
Right.
that's what was the order.
Right.
So sir, how can that happen? Because as you sir rightfully said that the SOAP message is sent back to the sender,
Right.
and body is modified during the backward journey.
Okay.
Modified by the
Intermediate.
No, whoever generated the fault will write the fault message as part of the body. That's the return body, essentially.
Sir, please, I'll come to my question. Sir, my question pinpointed is it the intermediate node generating a new SOAP message with a fault, or is it modifying that old SOAP message? It's
Generating a new SOAP message with the fault.
Okay. Then it is fine. No problem.
Can we have some fault tolerance kind of mechanism such that we have some alternative intermediaries that is if one fails, the message can be sent to some other alternative intermediary?
It's not part of the inherent SOAP specification to do something like that. Can you do that? Yes, you can, but you have to set this up yourself. Is that, for example, the sender of the message can trap the return fault that is coming back and understand it, and instead of throwing an exception back up the stack on the client side, we'll send it to somebody else or route it in some other way or whatever. Right? This would just be like, suppose there were two databases in your organization, right? So I was going to do a JDBC call or ODBC call to one database, right? Something happened, the database threw an exception. Right. Now, as part of the ODBC exception, my client stub would catch that and I would do something with it. Now, I have two choices. I can throw the exception up the stack to my client who called me as a stub, or I can say, wait a minute, there's another data source that I have been programmed with, so let me go to that data source and see whether I can retrieve the data. Right. I can do that silently, completely, without actually throwing an exception back up the stack. So it's something like that, and you can set that up here as well.
Can we send a SOAP message that can be multicast or broadcast a SOAP message instead of specifying a single ultimate receiver?
That is a protocol binding issue. There is no protocol binding for multicast currently defined on SOAP. So HTTP, there is no HTTP multicast notion, as a result of which there is no, same thing with SMTP. So there is one intended recipient. So you can simulate a multicast by doing many one-to-one messages, many point-to-point messages. Explicitly. Yeah, there is no inherent multicast binding that is defined on the protocol. Yeah.
So the question she asked, now she said she wanted to know if in case of an error or a fault, instead of throwing it back to the receiver, can we have some other intermediary node which is receiving this kind of error and trying to correct it? But this can actually happen, when we have two kinds of errors. We have two kinds of errors that arise out of faults in the data itself which we receive from the sender, and some errors, some system errors where our resources are not accessible to ourselves because of something going down. Database is down. In that case, there is actually no point in sending this error back to the client because client is not in a position to change our setup.
Right.
So this has to be done something, it has to be done internally by us where perhaps some sort of manual intervention is required. So in that case, this error has to be tapped and processed in such a way that something is alerted to go bring the database up.
Right. But if the SOAP server is up on the server side, but it cannot access resources it needs in order to perform the SOAP function that it is being called to perform, then the server can throw up an alert saying, hey, there's something wrong on the server side. I will send a reply to the client and I will alert my systems administrator that something is down on this side. Both can be done on the server itself. Right? You don't need any other intermediary to get involved in this. That's one way of handling it. Presumably there is also monitoring software and management software on the server side that is making sure that everything is up, it is pinging it, there are heartbeat pings that are going on these servers and so on. As the SOAP server itself is down, tough luck. I mean, nobody there to process the message. There's nothing I can do, right? So that will be a fault, essentially. That the client has to know that the SOAP server is down. right? So silently failing is generally not a good idea, right? If there is a fault, because it will take some time for the person to bring it back up. In the case of system to system services, right, or program to program communication, the communication is fast enough that if human intervention is required on the server side, then that will be exposed immediately. It's very hard to hide that fact completely. If somebody has to physically bring it back up. If there is a monitoring agent that can bring the software back up, then that can be done on the server side. The server can be written in such a way such that SOAP message comes, I have to access the database is down, I know how to bring the database up, the machine can bring the database up on its own by rebooting that box remotely. Let it do that, then everything will be fine. And then it can actually access the data and then send it back. But the reply would probably take 15 minutes to come back instead of, a couple of seconds or whatever. So, in the meanwhile, the client might have timed out, which is always an issue. So I think the bottom line is that given this base, many different processing models can be set up on top of this. It requires additional effort.
Sorry, sir,
right?
One more question.
Yeah.
One SOAP message cannot be sent to multiple recipients, right?
No.
It cannot.
No, you have to send it as multiple point-to-point messages. I just answered that question. Yeah. All right. So let's move forward. We actually are supposed to cover WSDL as well today, which is we should try to do that. So the web architecture is that. So we were talking about HTTP binding, and we know that in the case of HTTP, URI is the central notion, right? Everything is identified by a resource identifier in there. So what we don't want to do is that we don't want to do requesting to get a state of some specific piece of information that is identifiable by a URI, but we want to club that within the SOAP body. Right? In other words, here is an example. Okay, this is bad to do, and what are we doing here? What we want to do is to actually get back the details of this PNR, the reservation that has been made it has already been made earlier, and we want to get back the details of this PNR. So this is just information retrieval, remember, that is going on. Right? No state is being changed on the server side. But so the URI, this is the URI as it turns out. On the server side, every resource is identified by an identifier. This is a resource on the server side, the PNR reservation corresponding to this PNR. Right? Now the resource, the URI is no longer part of the HTTP message itself. Right? So the HTTP message is just being sent to some server. Right, it's just saying get back information in SOAP, but now there is a actual SOAP request as well. So I'm doing a post instead of doing a get in this case. Remember what we said, that the get should always be used for information retrieval and post when you want to change the state of the data. So this is not a good idea to do. Instead, what we want to do is this, where the URI is explicitly identified as part of this, because HTTP revolves around the notion of URI. The whole web, right, identifies things on the web by means of the URI, and if we take that information away, then it's generally not good practice, right? So in this case, in order to do a get, what I'm doing is I'm giving the URI as part of the get target, right? So that's one thing we want to keep in mind. So here is the SMTP binding for SOAP, just like we had the HTTP binding as well. And so there are some other features that you can take. So this is a one-way message exchange notion. Right? Unlike HTTP, which is a request response mechanism. Right? So the SOAP message correlation, which is the last bullet here, has to be handled at the SOAP level. So the underlying protocol will not handle message correlation for you in this case. So the SOAP may have to insert a piece of information that gives you the ID of the request that is being sent, and the ID of the ID of the request also comes back in the SOAP message, and then I will correlate the two things. Right. So here is an example of an email carrying a SOAP message. So from somebody to somebody, reservation request is going to be done. The content type is SOAP plus XML. That has to be specified in your email, right? So that the other person knows how to deal with it. And then you give your standard SOAP message, header and body, whatever that happens to be. SOAP response is carried in another email message altogether. In this case, actually there is some correlation information that is possible if it comes as a reply. So this is the correlation information that is being set up. So in reply to some message, you are sending back this. If this were not there, then you would have to do this at the SOAP level. right? So if this message ID was not there, you would have to do this at the SOAP level. Okay, so a little bit about SOAP extensibility. We'll actually cover this in much more detail on day 4, where different specifications, I will illustrate a bunch of different specifications, WS addressing, reliable messaging, policy, etc. But here's something about security where you can basically add security related headers in here as well, right? So there's some security token that is being passed, it's a 509 kind of a certificate, etc., etc., right? So this is included in the header. So that's what we mean by extensibility that we were talking about. So the fundamental nature of or the structure of SOAP messages don't change at all, except that you keep adding different information in the header depending on what is it that you want to, what kind of semantics you want to give to this system. So to do RPC, this is what you need, right? So these are the different elements that you need. Address of the target SOAP node, the method name that you're going to call. So remember, an RPC is a procedural call, so you need some kind of a procedure. Input arguments have to be given and results are going to be returned, right, as part of that. Right, and then the property values for binding. So what is, how do you want to actually bind this, and any other header data that you have. So here is a RPC request. This is the first part of the RPC request, not the whole thing. Right, so this says it's a transaction that we are doing to identify the fact that this is a request response. It has to be done atomically. The whole thing, request response, has to be part of one atomic message, right? There's some other header data that something must be understood. This number 5 in the context of this transaction has to be understood. It doesn't mean much for us. The method name is this happens to be a RPC request for charging reservation. So the credit card number is going to be given here and the expiration date of the credit card is given here. Then the reservation parameters itself have to be given, which is the PNR for which I actually have to make the booking, or the booking has been made. You have to charge this particular booking and confirm it, right? And then the credit card information, right, has to be given here. All this is part of the body, by the way. Right, the body contains the method name and the different parameters. So reservation parameters, credit card parameters are being sent out there. And then there is a response coming back. Now you can have the notion of out parameters or result, right? Return value of the result. Remember, when you write out a method or when you write out a procedure, you have input parameters, output parameters, or in-out parameters, right, as part of the procedure, and you have a return value. Right, so in this case there is no return value, but there are just 2 out parameters that are returned. Right, so charge reservation response, and as part of the response, the same code for which the reservation has been made is being sent back, and you can view it at this particular URL. Right. So here is another response that can come back, which has a return value and the 2 out parameters. So the return value is a status in this case. The RPC result is what we indicate it as, and then the 2 out parameters, which is the code and where it can be viewed at, which is a PNR and where it can be viewed at. Right. So in the previous case there was no notion of status or return value. Here we are giving both. There was an implied assumption that if you got back a view at and this thing, it was a confirmed status. Okay, so we'll step back from some of the XML and take a look at a slightly higher picture of how this is working out there. So this is the architectural view of SOAP. Right, so there is some client application code that you are writing. This is in some language of your choice. It can be any language of your choice. Let me make that clear. Right, and for every WSDL specification that has been written, suppose you want to contact some particular service, right? There is a WSDL specification. Out of the WSDL specification, you will generate a client stub and a server skeleton. Right? Now this is generated code, you don't have to do much. In fact, what you'll see today afternoon is precisely this. Right? So write some WSDL and you will generate the client stub and the server skeleton. Right? What the client stub does for you is it will basically take the request which is being called. So this stub is also generated in the language in which this application is being written. So if you had a Visual Basic application, this would be a Visual Basic stub. Right? C++ would be a C++ stub. So there are translators that will take WSDL descriptions and generate these stubs for you. Right? And then what this stub does is it takes the parameters and calls the XML marshaller and creates a SOAP message out of it. Right? So it creates an XML message, in other words. And then the SOAP message, which consists of this overall envelope, which has the header, multiple header blocks in the body, is then transferred over HTTP, over TCP/IP to the other side, and the other side is going to basically unmarshal the message into the language in which the server is implemented. There is nothing. These two languages have nothing to do with each other. They can be completely different. Right? This was a question that came up several times as well. So this could be in Visual Basic and this could be in C++. And so this unmarshals it into C++ objects, and then the request is then called here. Right? So the return path is very similar. So there is a marshaller on this side as well, which I have not shown here. Right? So for the return values, it will marshal it into an XML message and then ship it back, and then there will be an unmarshaller that is sitting here, which will translate that into the language objects of choice and give it back. Right? So that's the basic notion. That's how things work. That's how things work in all the distributed computing architectures, so distributed object architectures, CORBA, RMI, DCOM, all of them roughly follow the same architectural model. It's really not very different. Right? So in the case of web services and SOAP, it's an open format, therefore it is usable from any platform. It's not tied to any specific language or even any platform like .NET. It doesn't matter. .NET can do this as well as a Java platform can do this. Right? So it's, yeah.
So I have implemented one software. The server is PHP, PHP and the database is VB.
Right.
And the client is VB6. These two are interacting. So I have written some services in PHP and VB is calling.
Right.
When I started this implementation, there was not WSDL.
Right.
I used the new SOAP server.
Okay.
There's a freeware that is coming in. So it converts it into SOAP message. When I
so what converts it into SOAP message for what?
PHP new SOAP converts that. I'm just.
So the PHP is being wrapped as a SOAP service.
New SOAP.
Okay.
SOAP is a server.
Okay.
SOAP server.
Fine.
So that wraps it.
Right.
Wraps the data that I want.
Right.
Sending a request from VB6.
How do you send the request?
As a get message.
As a get on. Okay. That's fine too.
To the server from VB6. And from there, it is wrapping it.
Okay.
All the data records.
Okay. It's coming back as a SOAP message.
As a SOAP message.
How do you process it?
And there was no stub. That's what the question now.
But how do you process the SOAP message?
And that SOAP, it's a new SOAP in VB6. There's a
there is some utility.
Object.
Alright, fine. So that is playing the role of the stub essentially for you.
It's playing the role of the stub, or it is directly reading the body. That's what my question is.
No, see, what is the stub? The stub is specific to the kind of, to the signature on the server side that you are calling. So suppose there is a make reservation method on the server side, right? Now the stub is generated to look exactly like a make reservation method, right? Or a procedure. And so if make reservation takes 15 parameters, this will also take 15 parameters and create an XML message for you. Now what this VB thing is doing for you is essentially playing this same role, right? So whatever SOAP comes back, it knows how to read that SOAP message and then pull the data out of it and then giving it back to the VB application. So that's some utility that has been written by. Okay, right. So I think in .NET it looks a little more like this rather than the other way. So.
Sir, how to distribute this stub to the client?
It is actually generated on the client side itself. It's not generated on the server side. So what happens is, remember the picture that I put up earlier. A WSDL description is gotten back from the server. From the WSDL description, you will generate the client stub and then use it. Right? So there are things that can do this dynamically as well. So it can read the WSDL description, dynamically generate a stub and allow you to invoke that stub. Right?
So one more question is that, what friend had asked. In that particular scenario, is it a remote method invocation happening?
It is. It's exactly a remote method invocation. Both sides it is a remote method invocation.
RPC.
Exactly the same thing.
The stub would be required.
Well, it's kind of embedded in this case. There's some kind of a tool that is playing the role of a stop.
Breaking it into, then I'll use DOM. So convert it into DOM. Then I'm using.
So he is doing the DOM process. You are doing the DOM processing yourself. So that here the thing, a regular SOAP server would do that processing for you and then give you back language specific objects of some kind. Okay. So if you look at CORBA, it also looks exactly the same. It doesn't look very different, as you can see. Right. So there is something called dynamic invocation. So if whatever I describe, right, that stub has to be available to you beforehand. It has to be compiled, linked with the client program, right. So it has to be generated, compiled and linked to the client program. So that is static in nature. So invocation is static. A priori you need to know what the service looks like. But that's not good necessarily, right. What I want to do is discover a service dynamically and then bind to it and use it. That is the notion that I am trying to eventually get to. In order to do that, CORBA has something called a dynamic invocation. What it does is it reads this IDL that is coming back, and when it reads the IDL, there is some kind of a inspection API that CORBA provides that says this IDL exposes these methods. If for each of these methods, these parameters are required, and this is the type of the parameter, right? So on the fly you can do something like this is very similar to reflection in Java, right? So similar to reflection, this gives you a reflection API. CORBA itself gives you a reflection API because it is not tied to a specific language, right? So using CORBA API you can read the IDL, which is the interface definition language description of what has to be called, and create a message for it on the fly, right? If you have the types of those parameters with you, obviously. Right? If you don't, it's not possible for you to do that. So if you have those parameters, you can find out. So because there could be different IDL descriptions that could even, where the order of the parameters may be different. And so you don't want to hard code that into your application upfront. This is a little slower because you're using reflection, and using reflection is a slow process because you're constructing the message dynamically at runtime. So it's a little slower, but it gives you a lot more flexibility. It looks the same though. So we'll just analyze these different technologies briefly. That's kind of what we'll use to wrap this up finally. So in terms of scalability, it's a stateful programming model for CORBA, and that's not necessarily a plus. This minus and plus are relative things, right? In some cases it could be very useful. The activation notion is that in terms of shared activation, if a CORBA object is not actually running, there is a CORBA runtime that will be able to deploy that object at runtime and then call it automatically. That's what's called activation. And that shared activation notion is it's common to all kinds of CORBA objects that are deployed on that particular CORBA server. That's all that says, right? So in performance there is no notion of intermediary here. It's just direct client to server interaction, right? The transport is binary. The IAOP notion is actually binary, so it's actually faster because of that, which is why a plus is indicated there. You can specify different policies for how you want to activate these services. Should I throw an exception? Should I automatically activate the service? Should I send a message to a systems administrator to activate this? Are there permissions for some client accessing me by which I will automatically activate? All kinds of flexibility is provided there, right? Connection oriented protocols are used in CORBA. There are no connection-less protocols that it is mapped to. Garbage collection, it depends. Some vendors provide it, some vendors don't. So, security uses SSL. There is no separate security spec as such, right? So if you take a look at Java RMI, this is RMI over IAOP, not RMI over JRMP. There are two different protocols. Even the underlying wire protocol can be different. Remember, RMI is an application level thing, right? So wire protocol can be IAOP or JRMP. So this is RMI over IAOP, which is the same protocol that is used by CORBA as well, the wire protocol that is used by CORBA. And the reason why you have this is for interoperability purposes. So if you have a Java RMI application that needs to talk to a CORBA application, then you would use RMI over IAOP, right? So It looks very similar, so there's no real point going over this. Otherwise, this is the other choice. So GRMP is your other choice. It's a proprietary protocol that is proprietary to Java. This is a little faster than IOP as it turns out, but you lose that flexibility. So in the case of RMI, there is a notion of a registry, right? So you will pick up where this RMI object is deployed via registry. The same thing is actually true with Corba as well. There is something called a naming service in Corba, and you will actually expose the fact that you are running at some particular server via a naming tree, right? Here you have JNDI as well as a RMI registry. If you use JNDI, it is more of a naming tree structure. An RMI registry just says where you are running as a server. Right. So performance, I think you have experience with some of this stuff. The advantage with Java, the biggest advantage is that you have code portability. Right. If you have a Java client and a Java server, then I can actually download the stub at runtime as a class. It comes back as a class, and then I can use objects of the class that I create. Right. And I know it's going to run in my thing because my thing is also a Java VM. So that way I'm all set. So this code portability is a very, very powerful concept. And in fact, remember we talked a little bit about this notion of Gini and Juxta, which are other instantiations of SOA out there. It uses code portability. So what I actually register with a directory is not a WSDL type of description, but I will register a stub. I will actually register how these people should call me via a Java class that I create, and I register the Java class, right, with this directory. And so somebody else can simply download the Java class at runtime and use it. It's a very, very powerful feature to have. But of course, that only works if your client and server both are written in Java. That's the right. Okay, so they do distributed reference counting based garbage collection as well. It's reasonably powerful actually. Right. So the security thing is actually integrated with the language as it turns out. So it is not just for RMI, but it's within Java the language they have good security management. So with SOAP it can be scalable if your request response model over HTTP is done, because HTTP is fairly fast, right, by itself. The main processing overhead comes in the XML processing. That's where we have to worry about, right. So that's what this is saying. So, okay, so there's a spelling mistake here. If you're interoperating between architectures, the overhead is not unreasonable. Right? No activation, no garbage collection, none of these things are specified as part of SOAP. Right? So it is stateless. So that's one aspect of it. Security is, there is a WS security spec which is pretty exhaustive. That is also part of the specifications now. We'll discuss that as well. Otherwise, you can, if you want to avoid this, you can use your standard HTTPS, using SSL. That's one way of doing it. That may not be enough for you, right? It may not give you authentication and things like that. So there is no standard serialization methods. You can pick up any which one you want. So there are different bindings that are proposed, and different people can be working with different bindings. So there is no one standard. So it's truly vendor agnostic. I think that's the biggest plus for you if you're using SOAP, is that it doesn't matter. The server can be written with one vendor's product, and your client would be written with a completely different vendor's product, and the two of them can interoperate. So version handling, I don't know whether we need to discuss this. I talked about it already. 1.2 node receiving a 1.1 message has different choices to it. 1.1 receiving a 1.2 message will simply generate a version mismatch fault and send it back. There's no choice there. So this case is possible, and so your version mismatch error looks like this. So it can actually send an upgrade error. It can the SOAP fault should include an upgrade SOAP header block in that case. So that's what this is showing. Right. So if it says upgrade it and process it in that way, then it will do it. Otherwise, it will generate a fault saying there's a version mismatch. So that's a high-level overview of SOAP. some more details can be gotten in the book references that I just gave out. Certainly if you go to W3C itself, the original specifications for SOAP, detailed architecture documents are all available that you can wade through. It's going to be quite useful for you to do that.